Hello grade 8 students. For today, we will be discussing word problems involving rational algebraic expressions. In today's lesson, you should be able to solve and analyze word problems involving rational algebraic expressions. Without further ado, let's have with our first example. We have here a triangular lat has sides that measures 4x over x squared minus 9 meters, 2x minus 1 over x plus 3 meters, and 5 over x minus 3 meters. The question is, what is the perimeter of the lat? Let's visualize our given problem. We have here a triangular lat with sides of 4x over x squared minus 9, 2x minus 1 all over x plus 3, and 5 over x minus 3. In this given problem, we are looking for the perimeter of the triangular lat. To find the perimeter of triangular lat, we have the formula s plus s plus s, or we will just add all the sides of this triangle. So for our first side, we have 4x over x squared minus 9. For our second side, we have 2x minus 1 over x plus 3. And for our third side, we have 5 over x minus 3. To add this given expression, we need to find the LCD of x squared minus 9, x plus 3, and x minus 3. We know that the factoid form of x squared minus 9 is x plus 3 times x minus 3. Therefore, this will be our LCD. X squared minus 9 divided by x squared minus 9 times 4x will be the same because x squared minus 9 divided by x squared minus 9 is equal to 1 times 4x plus x squared minus 9 divided by x plus 3 times 2x minus 1 will be 2x minus 1 times x minus 3 plus, with our third fraction, x squared minus 9 divided by x minus 3 is times 5 is equal to 5 times x plus 3. Now that we have same denominators, we can just copy it and add our numerators. But before that, make sure that you simplified all your numerators. In this given example, we simplify our second fraction using the FOIL method. So we will have 2x squared minus 7x plus 3 as our new numerator. And for the third fraction, we use distributive property to simplify 5 times x plus 3. Now that we have same denominators on our fractions, so we can copy it and combine like terms. So we will have 2x squared plus 2x plus 18 all over x squared minus 9 meters. Therefore, the perimeter of this triangular lat is 2x squared plus 2x plus 18 all over x squared minus 9 meters. Let's have second problem. A rectangle has length of 3w minus 5 over w plus 1 units and width of 2w squared minus 3w minus 5 all over 5 minus 3w units. What is the area of the rectangle in square units? Let's visualize our given problem. We have here a rectangle with a length of 3w minus 5 over w plus 1 and width of 2w squared minus 3w minus 5 over 5 minus 3w units. We are looking for the area of a rectangle, which is the shaded region. To find the area of this rectangle, we have the formula length times width. We have our length, which is denoted by 3w minus 5 over w plus 1 times our width, which is 2w squared minus 3w minus 5 over 5 minus 3w. To multiply this given expression, the best thing that you can do is to factor all your trinomials and your terms. So we can factor 2w squared minus 3w minus 5 by w plus 1 times 2w minus 5, and then just copy your denominator. As you can see here, we can cancel 3w minus 5 and 5 minus 3w if we will factor negative 1 with our denominator. So we will have negative 1 times 3w minus 5. As you can see now here, we can cancel 3w minus 5 as well as w plus 1 on both numerator and the denominator. So we will have 2w minus 5 over negative 1, or negative 1 times 2w minus 5, or if we distribute the negative sign, we will have negative 2w plus 5 square units. Therefore, the area of this rectangle is negative 2w plus 5 square units. Let's have example number 3. The length of the rope is 8y squared plus 19 over 2y squared minus 8 units, and it is cut into 3 parts with the following lengths: 6y minus 1 over 2y squared minus 8 units, and 4y over y plus 2 units. Find the length of the third part of the rope. Let's visualize this given problem. Given that we have a rope with a length of 8y squared plus 19 over 2y squared minus 8, and it was divided into 3 parts. The first part is denoted as 6y minus 1 over 2y squared minus 8. The second part is 4y over y plus 2, and we are looking for the third part of the rope. To find the third part of the rope, we can have our working equation, which is length minus the first part minus the second part. So we have the length, which is 8y squared plus 19 over 2y squared minus 8, minus the first part of the rope, which is 6y minus 1 all over 2y squared minus 8, minus the second part of the rope, which is 4y over y plus 2. To subtract this given rational algebraic expression, let's find out first the LCD of 2y squared minus 8 and y plus 2. We know that the factors of 2y squared minus 8 are 2, y plus 2, and y minus 2. Therefore, our LCD would be 2y squared minus 8. As you can see here, we just copy 8y squared plus 19 on our numerator because the LCD and our denominator are just the same, as well as with our second fraction. On our third fraction, we will divide 2y squared minus 8 with y plus 2. We will have 2y minus 4 and multiply it to 4y. To simplify this further, we can combine these fractions because we have same denominators. And now that we can subtract our numerators. But take note, in subtracting rational algebraic expression, you need to distribute the negative sign to the factors inside the quantity. In this given example, you distribute negative 1 to 6y. That's why it became negative 6y. Negative 1 distributed to negative 1. That's why it became positive 1. Negative 1 times 8y squared become negative 8y squared, and negative times negative 16y became positive 16y. As you can see here, we can cancel out 8y squared and negative 8y squared. Therefore, we will have 10y plus 10 over 2y squared minus 8. We can also factor this out using common monomial factor. So we have 10 times y plus 2 all over 2 times y minus 2 times y plus 2. As you can see here, we can cancel y plus 2 on the numerator and the denominator. So we will have 10 over 2 times y minus 2. We can also simplify it by dividing 10 into 2. So we will have 5 minus y minus 2. Therefore, the length of the third part of the rope is denoted by 5 over y minus 2 units. Let's have our last example. Find the length of a rectangular plot if one side measures x plus 1 over 2x minus 1 meters and the area is 3x squared plus 6x all over 6x squared minus 3x squared meters. Let's visualize this given problem. For example, we have a rectangular plot with the area of 3x squared plus 6x all over 6x squared minus 3x and with a width of x plus 1 over 2x minus 1 meters. We are looking for the length of this rectangular plot. To find the length of this rectangular plot, we have the formula, the area of the rectangle divided by the width. So we have the area of rectangle, which is 3x squared plus 6x over 6x squared minus 3x divided by x plus 1 over 2x minus 1. The first thing that we need to do is to get the reciprocal of our divisor and change our operation to multiplication. So we will have 2x minus 1 over x plus 1 as our new multiplier. To easily multiply this given expression, we can factor this polynomial. We know that the factor of 3x squared plus 6x is equal to 3x times the quantity of x plus 2, and we can factor 6x squared minus 3x as 3x times 2x minus 1, and then we copy our second fraction, which is 2x minus 1 over x plus 1. As you can see, we can cancel 3x and 2x minus 1 on both numerators and denominators. So we will have x plus 2 over x plus 1. Therefore, our length is x plus 2 over x plus 1 meters. It's your turn. Answer the problem of the day. Elisa walks from her house to a store to buy a pen before going to school. If the store is 3 over x plus 3 km away from her house and 4x over x squared minus 4x minus 21 km away from school, how far is Elisa's home from school, assuming that her home, the store, and the school is on a straight line? Pause the video for a while and we will reveal the answer afterwards. The correct answer is 7x minus 21 all over x squared minus 4x minus 21 kilometer. That's all for today. Thank you and God bless. Do not forget to access your Keeper accounts for a short assessment. Don't hesitate to ask Miss Ria and Sir Alex for further questions. Thank you.